Everyone should know when it is written log, it implies log base 10. Log base 10. Uh, it can be written as LG, and that is called common log. Common log. And when it is written ln, that is natural log, that implies log base e, that is natural log. Natural log. But what is e? E is a Euler number, or you can say it irrational constant, because e has a constant value. We know e equal to 2.718. This value is constant, so we can say it as irrational constant. But I know there should be a lot of discussions about e, but now in short I can say e is a constant growth rate, and I'll explain it in another video for you. Let's get focused on base changing formula now. In logarithm, the change of base formula is used when we use the calculator to find the value. Generally, the calculator has two buttons. One is log, which implies log base 10, and another is ln, which implies log base e. And these two are the most commonly used bases in logarithms. But in some cases we feel the necessity to change the base to calculate the value, and mainly for solving exponential equations. This is the reason why the change of base formula is formed. In solving exponential equations, we can convert the base as our choice by using this formula. So in that case, it is very useful property. Now the formula states log b to the base a equals log b to the base x over log a to the base x. Here the argument will be in numerator and the base will be in the denominator, and the both numerator and the denominator will obtain the same base x. Here x is an arbitrary base. It will be changed as required, and there are some conditions for them. For this formula, the base, that means x, will be greater than 0 and x will not be equal to 1, and the arguments, that is b and a, both will be greater than 0, and these conditions, they will follow. Let's solve an example. Here I am taking log 17 base 3. Log 17 base 3. So how can you calculate the value by using this formula? I am writing it again. Log 17 base 3. Log 17 base 3. I can write it as log 17 base 10 over log 3 base 10. I am taking base 10 first, and then I will take base e. Now from the calculator I have the value log 17 base 10 equals 1.2304, and log 3 base 10 equals 0.477. That is equal to 2.578. And now again log 17 base 3 equal to I am now taking log base e, that is ln 17 over ln 3, and from the calculator I have the value of ln 17 2.578. 1.8332 and ln3 equal to 1.098, that is equal to 2.578 also. So it doesn't matter how we can calculate, the result will be the same. We can also derive another formula from this one, from this log base, log b to the base a. I am writing it again. Log b to the base a equal to, we know log b to the base a equal to log b, we can write it as log b to the base x over log a to the base x. And if I divide the numerator and denominator with log b base x, that is, I am writing log b base x over log b base x over log a, now the denominator, log a base x over log b base x. Then the upper one will turn 1 because log b base x over log b base x equal to 1. And now look at this, log a base x over log b base x. And if I apply the base changing formula in this, so I can write it as log a to the base b, because the argument will be the numerator and the base will be the denominator. That's why it is log a to the base b. Therefore, I can write log b to the base a equal to 1 over log a to the base b, and also written as log b to the base a into log a to the base b equal to 1. And these are also very useful properties. So today we have learned all about the base changing formula, and I think it will help you to get across the lesson. So thank you for watching, and please like and subscribe my channel.